Hi friends, today we're going to talk about solving a two-step linear equation. Now just to recap, if it's a linear equation, that means that the variable is raised to the first power. And I like to think of that as a sneaky first power because we don't usually write it. We just look at it as x or y. An equation, remember, has an equal sign. And so that means that we can do the same thing to both sides of that equal sign. Or you'll hear me say, what you do to one side, you'll have to do to the other. We talked about one-step equations in a previous video, and so these equations are going to have both an addition piece and a multiplication or division piece. Also, it could have subtraction. Addition or subtraction, and multiplication and division. So I want you to remember, think back a long ways to when we talked about order of operations. And we talked about the sequence in which we are going to evaluate an expression. And remember, we had rules for that. So remember, this was parentheses, exponents, and then we had multiplication and division from left to right. And then we had addition and subtraction from left to right. So we got comfortable with PEMDAS here, our order of operations, and now we're going to use it when we're solving equations. But here's the catch. When we're solving equations, we are working PEMDAS backwards. So we are starting with the addition and subtraction piece. And then we are doing the multiplication and division piece when we are solving equations. Okay, so remember that first we're going to use addition and subtraction to combine our like terms. Let me write that one down. We're going to use addition and subtraction to combine our like terms. Now this could be the x's, or it could be the numbers. It could be the numbers, or it could be both. And then the second piece is we're going to use multiplication or division to solve for their variable. All right, let's try a problem. So let's try an example. I have 2x minus 1 equals 5. Now remember, the first goal is to collect our like terms using addition and subtraction. So I'm going to go over to this equation and I'm going to notice that my like terms are the numbers, this minus 1 and this 5. So to put them together, we need them on one side of the equation. So I'm going to move this plus 1 over to the other side, and the way I do that is by doing the opposite of minus 1, which is adding 1. Now when I do that, the minus 1 and the plus 1 go away. I'm left with 2x on the left-hand side. And on the right-hand side, I have 5 plus 1 gives me 6. All right, so all we did there was we used addition to collect our like terms. And remember, 2x and 1 are not like terms, so they can't get combined together. All right, now I have 2x equals 6. This should look familiar. This is just a one-step equation. And remember, to undo multiply by 2, we're going to divide by 2. Those 2's will cancel. So I have 1x. And I'm just going to write x down, equals 6 over 2, which is 3. So we end up with a solution of x equals 3. Notice we did our addition first, then our division to get our answer. All right, let's look at another one. All right, I have the equation 12 minus 5x is equal to negative 3. So the first thing I want to do is notice, well, I have a 12 and a negative 3. Those are like terms. That negative 5x is not like, so we can't combine the negative 5x with those, but we could combine those numbers together. And to do that, I'm going to need to use addition and subtraction. So this 12 is a positive 12. We don't always write that plus on the outside. It's a sneaky plus. It's there. We just don't always write it. But it's important because we want to remember, how do we undo positive 12? Well, that's with subtracting 12. So I'm going to subtract 12 on both sides of the equal sign. When I do that, these terms will go away, the positive 12 and the negative 12, and I'll just be left with a minus 5x. On the right-hand side, I have minus 3 minus 12, which would give us minus 15. Cool thing here is now we're just at a one-step equation. How do we undo minus 5 multiplied by x? We use division, and we're going to divide by negative 5. Now, notice I'm only dividing by negative 5, not by the x. We want to get that x all the way by itself on the left side of the equation, and we can't do that if we divide by it. So minus 5 and minus 5 will cancel. I'll be left with a 1. 1x, so I'll just write x. And then on the right side, I have negative 15 divided by negative 5, which is positive 3. We know we're at an answer because we have the variable all the way by itself and equal to a number. All right, let's look at another example. All right, 4x equals 12x minus 2. Now I did something sneaky here. My like terms, I switched what they were. They're not the numbers anymore. Now, the like terms that I would like to combine are the terms with an x. So 4x and 12x are my like terms. I'd need to get them on one side of the equation. And in order to do that, I need to use addition and subtraction. So I could subtract 4x from both sides, but then I'd have everything on the right-hand side. It wouldn't be wrong, it just wouldn't help me very much. So instead, I'm going to subtract 12x from both sides of this equation. Now when I do that, the positive 12x and minus 12x will go away, and I'll just be left with a minus 2 on the right side. On the left side, I have 4x minus 12x gives me negative 8x. And you can see why I did that, so that I have x's on one side, numbers on the other. All right, so now we have a one-step equation. So negative 8 times x. How do I undo that? With division. And what we divide one side by, we have to divide the other as well. The negative 8 in front of the x and the negative 8 in the denominator will cancel, leaving me with 1x or just x. On the right-hand side, I have negative 2 divided by negative 8. I can write that, and then let's talk about what it means. When I have a negative divided by a negative, that is going to be a positive number. So I could also write it as 2 over 8. And then we want to think, can I reduce that fraction? They're both divisible by 2. So I'm going to divide the top by 2 and the bottom by 2 to reduce that fraction and get 1/4. Now, that would be my final answer, x equals 1/4. Okay. And again, we know we're done because we have our variable by itself equal to a number. All right, let's do one more example. I'm going to start it right here. And this is when I have both variables and numbers on both sides of the equation. So we first want to use addition and subtraction to combine our like terms. So I'm going to mark my like terms here, the 3x and the 5x, and then also the -1 and the -5. So let's start with the x's first. I'm going to get all the x's moved over to the right-hand side and all of the numbers to the left-hand side. In order to do that, I'm going to add and subtract one of those terms with the x. Remember, we have that sneaky plus on the 3x. We don't write it, but we know it's there. We're going to subtract 3x to undo that positive 3x. 3x minus 3x is 0. So on the left-hand side, I'm left with -1. On the right-hand side, I have 5x minus 3x is 2x. And we keep the -5 from above. Now it looks like a question we tackled over on this side of the board. So, remembering we have that second set of like terms, the numbers, we're going to move all the numbers to the left-hand side. So instead of -5, to undo that, I use +5. On the left-hand side, I have -1 plus 5 is equal to 4. And on the right-hand side, -5 and +5 undo one another, and I'm just left with a 2x. Okay, we're almost done. Looking at that x, why is it not by itself? Because it's multiplied by 2. So we are going to divide both sides by 2 to undo that. 4 divided by 2 is 2, and that is just going to be equal to x. And I know I am at a stopping point because my variable is by itself and it's equal to a number. Now, in the next video, we'll talk about what happens when you add in parentheses to a two-step equation. So we might call that a multi-step equation because, well, it's going to be 3 or more. So master these skills first, and then you'll be ready for the next one.